Okay, okay. So here are some extra examples. We did these in class, or just in and maybe you have to go back look at it, or you missed class, whatever it is. But here are some extra examples from section 2.6. Um, Again, if this isn't making sense even at this point, come in before after school. A lot of times I can sort these problems out pretty quickly. So anyway, number 13, they want us to, for 13 through 15, give the property that states what that justifies this being true. So hopefully for 13, you would pretty quickly realize, oh, that's just the distributive property. Okay. Number 14, okay, number 14, this one it depends upon how whoever's writing the answer feels. Personally, um, I prefer to go with substitution here because what I'm doing is I'm replacing with a value. I'm replacing a value, excuse me, with an expression. I only like to use transitivity if it's like a number 15 where it's all either all numbers or all objects. But if it's numbers and objects, it's substitution because I'm replacing 25 with 1 and 2. However, on 15, I'm saying AB equals BC, BC equals CD, so the length of those segments are the same. So they have to be equal to each other. That is transitive property. And then number 16 again, actually, 3 times x minus 2/3, 3x minus 2 equals 4. That's again the distributive property. Number 14 and 15, though, is tough. They really are, because you could argue this is transitivity. Hey, both 1 and 2 are equal to 25, therefore they're equal to each other. But it feels like, in this case, if it's a measure in numbers, the book is a big fan of saying substitution, because in their opinion, I think they're saying you're just replacing a number with something else. So I would go with either one, and I wouldn't have a problem with it if you said transitive property for number 14. 15 is definitely transitive. It is not substitution. Two things are equal to the same thing, therefore they're equal to each other. All right, next example. This is one of the ones the book likes to use, is a segment example. So they've told us that if AB is congruent to CD, then x equals 7. So what we're actually doing is we're doing a proof here. So our first thing, we got our statements and reason. We'll do our T-chart. I always do an S and an R because I'm lazy to do all that. The first thing is the given. AB is congruent to CD. Okay, one that's given. Now, like on the notes video, here's where we have to translate. If things are congruent, that means their measures are equal. And what's the measure of AB? It's 4x minus 6. What's the measure of CD? It's 22. I can't just say 4x minus 6 is congruent to 22 because this means objects. Excuse me. This means measures. So step 2 is saying that AB is equal to CD by definition of congruent. Number 3, step 3 then says, okay, now replace 4x or AB with 4x minus 6. Replace CD with 22. That is substitution. And it's not transitive because that would be AB equals CD, CD equals something, AB equals, this is just flat up replacing these both sides with equivalent expressions. And then step 4 and 5, addition property. So 4x equals 28. And then step 5, divide by 4, x equals 7, division property. Okay. The geometry part is right here. The rest of it's algebra. Okay. Another example similar to this one. With angles, same thing. So this example really is the exact same, it's just with angles now. So we've been given that MPN, which is this angle here, is congruent to QPN, which is this angle here. So we're going to do, if we know that, we're going to say x equals 16. So, again, statements, reasons. 1 is our given. We always start with the given. It's given that angle MPN is congruent to angle QPN. Now, if I want to replace what what it's equal to, I have to actually say it. So the measure of angle MPN is equal to measure of angle QPN by definition of congruent. Okay. And then step 3, okay, now they know those are equal, I can replace what they're equal with on both sides. So x plus 26 equals 2x plus 10. That is substitution. And then step 4, subtraction. You get 16 equals x. And now here's the thing. We're supposed to prove that x equals 16. What we've said is that 16 equals x. Now here's where those other properties come into play from earlier. If I want to swap the order, I can do that and say x equals 16 by the symmetric property. And that's what the symmetric property is for. Now, realistically, you know, this is just me being very picky and a big jerk if I make you do this. And normally I don't bother with it. But there is a reason we have the symmetric property of saying, hey, if something is in one order, why can I switch it for the other order if there's equality? Well, if I say 16 equals x, I need some property that says x equals 16. Okay. All right, and that's section 2.6. So again, if that, you know, looking through that and you're getting ready for a test or you missed the class or something and it doesn't make sense, because really those 2 videos don't cover everything, come in, see me, we'll talk, I'll go through any example you want, and we'll make sense of it.